Okay, it's all yours. All right, so we're going to start off today with how we like to start every Thursday. Trung is going to give one of those, let's talk about something cool happening in the industry, and then we'll analyze it afterwards.
Okay, so this is a longer video than I want it to be, but it will be cool to see. So this is the project I worked at Epic. This is the VR editor. I'm just going to play the video, and it will show you guys the demo. So this is recorded at GDC 2016, last spring.
You can switch into VR mode, and you can go back and
Oh,
forth.
sorry.
Back and forth.
How do I make sound of...
It just comes to the laptop.
Oh, it's come through a laptop? Okay. 1 second. How do I make full screen again?
I just closed the inspector.
The inspector. There we go. Okay. 1 second, let me make sound. Oh.
Do you need the sound?
Yeah, I need the sound.
It's not going to, I don't know.
Okay, I will just narrate it then.
Personal sound.
Okay, so this runs inside Unreal. This is actually a mode you guys can turn on. In the drop down, there's a preview VR, and there's a VR mode. You have to actually enable this feature in the project setting, but it would drop you out in the editor, right this, and then you can use the motion controllers to interact with the world. So as you see, if you move around the world, the way you move around, you kind of pull like this. This is how you move around in the editor. You can scale up and down. So the grid count tells you the relative scaling. So you can see from top down. Scaling helps a lot with just placing models and see how everything works. And you just scale back to the regular scale. Okay. And move around, rotate. There's no rotation like this because it's actually to get music. So right now only rotation is just around the up vector. There's no rotation around the V and the X and the Y axis. Okay, and you have access to the quick menu. This quick menu gives you can open the content browser, get all your assets just like regular editor.
Oh, that's so cool.
Rotate, scale, transform. You can turn so it snaps to the ground always. Yeah, so this is copy and paste. So that duplicates the model.
So the controls when you're placing things and interacting with things, it's very one-to-one.
Duplicate the model, rotate it. It can also snap to the object.
So Trung worked on this, and that's why he knows literally everything about Unreal.
Not everything, no. Not everything. There's so many things I don't know. You can throw the objects away you want. Yeah, because if you actually swing, it actually has a little bit of momentum and the object flies away a little bit.
So cool.
Yeah.
So real quick, just you don't have to pause, but see these windows that are popping up? Those are 2D widgets from the editor. People were talking about in their demos using 2D widgets as UIs. There's a blueprint that actually takes a 2D widget and renders it onto a plane in 3D space. So if you really want to hack a 2D UI using VR, you can do that.
Yeah, so this is all the 2D UIs is rendered onto a plane. I personally don't really like this type of UI a whole lot. I don't know, it feels kind of hard to read. Yeah, it's not natural because actually in 3D, why you want to look at the flat text, it's just not appealing. In Toothbrush, when you guys saw it, it was actually a 3D thing that you rotate around all the UI, which is something that's the most natural interaction with the environment. But anyway, yeah, that was my boss.
That's your boss?
Yeah. So this introduced you guys a little bit of another tool in Unreal. If you're ever interested into actually debug while you're in VR, you can be able to see the scaling, everything, and actually test out again, because you actually can play it again, but you don't have to take off your headset or anything. You can just sit in there, hit play, it just automatically starts playing also. You can play, edit, so have a really fast, iterative cycle through your development. It'll be interesting to try out. Unreal has this, Unity also has VR editing mode. Oh, sorry, questions? So you not getting sick because you see this grid that they have here. This is a trick that they use to make you not sick. If you have this is why the grid never change scaling, whenever you scale up and down. So you see the grid that show up when you scaling. I don't know. You guys see the
purple lines, right?
Yeah, the purple line. You see that grid. That grid always has the same scale no matter what. It always pops up whenever you move around or scaling. It pops up with the intention so that you have a point of reference always. So you feel like you're actually standing on the plane and everything else is scaling according to you. So that's a trick that I added. That allows you to actually also do this like pulling yourself forward, but it feels everything pulls forward you instead of you actually moving forward because the grid is relative to you. Everywhere it goes. And it has some fading and stuff like that. So that was a trick that was used. Yeah. Oh shit, it's jittering. I think it was just, at this point, it's just a prototype. So, yeah, this feature is experimental. It's not fully released or anything like that yet. So you actually have to turn on the experimental mode. Yeah, that's why I also don't like kind of the way it's being controlled right now. It would be nice actually like relative to where your hand is, relative to where your headset or something like that, rather than just in the wall just shaking like that. Yeah, cool. Anyway, if you have any questions about this, feel free to ask me. Okay.
Awesome. Thanks, John. Okay, so getting back onto our normal schedule. As you guys have seen in the project description, one of the main things that you have to do in your game is multiplayer. So that's kind of scary, right? Like, how are you going to network players and all that stuff? Yeah. Yes. Let me just check OBS and make sure it's working. Yeah, it's recording. Yeah, so today we're going to go over multiplayer. I'm about to throw a lot of words and complicated concepts at you guys. This is recorded, as Krishna mentioned, so please feel free to watch it again. Also, like, it will always help you to do all of this stuff in pairs, because there's a lot of just like you have to follow something and fit all of what you do into a puzzle that will break if one piece is like slightly out of order. So it always helps when you have a second person there kind of checking you and making sure that you guys are not like off by one errors, right? That will be really important. So just word of advice. So we're going to start with client-server modeling, move on to what hosting and joining are, best practices, subsystems, and then we're going to talk about replication and authority. So replication and authority are specific to Unreal, but everything else in this lecture is generic to any kind of network game engine. But before we get there, I want to talk about something really cool. So today is kind of like a jumble of cool stuff. There's this thing called a fast inverse square root. This is totally off topic from networking, but if you guys remember when we were talking about materials, a lot of our conversations were talking about how you can teach the computer to calculate how light reflects off an object. So how light bounces off this table in front of me, or how light bounces off my computer screen. Since all of those properties of light come in as vectors, right? So three-dimensional ray, origin and direction, you have to do a lot of like magnitude-oriented operations. So like square root of x squared plus y squared plus z squared is like a very common thing. So back in the day, John Carmack is like a graphics legend. He worked at id Software. I think he's CTO of Oculus now. Someone can check me on that. But he is the father of a lot of modern graphics, and he basically turned an operation, so 1 over square root of x, that used to take like, I think it was on the order of like 100 CPU instructions, and turned them into something that could basically be done in like the same time as it takes to multiply a times b. And I'm about to show you what that is. And I didn't write this next slide. This is the source code from Quake 3. This is a magic number. No one knows why this works. Even the programmer, he literally said what it says there. But for some reason, when you take a light vector and you cast it through a pointer to long pointer and get the memory address of an integer, a float, shift it right by 1, and then subtract it from whatever this thing is, it does a 99 point something % approximation of 1 over square root of x.
Because the way the long whatever that's like with a bubble or some sort of IE like value storing that the exponential is at the correct spot.
Exactly. So that's why. So essentially, you're taking like a floating point number, coercing it into a long integer, so 64-bit integer or whatever that is, and then when you cast it back to a float after doing a shift and subtracting from this magic memory index, the point in the floating point number, the bit that actually signifies where it divides the fraction from the exponent, is in the right place to do 1 over root x. Like, anyway, cool graphics things. Totally off topic.
I believe this only works as long as 4 bytes long and not 8 bytes
Yeah,
long.
sorry, 4 byte long. But yeah, implementation dependent. This game was written in assembly and C, so like that's why they needed this to be fast. But yeah, anyway, moving on. So totally random, but I thought that's something that everyone in graphics will at some point hear. Okay, so games are extremely network intensive. You guys can imagine why. Who can give me a reason why games take a lot of network bandwidth? Who can think of one thing? Anyone? Move on to Jason.
Just the player is just constantly moving.
Exactly. Everything is relevant, right? Fractions of a second can make a difference in how a game is played. So because of that, network games work over UDP, so User Datagram Protocol. That's a way of transmitting packets from point A to point B that says this packet going from A to B is not guaranteed to get there. Like computer A will send to computer B and not give a crap whether computer B gets it because it's not relevant. And there's so many packets that it would take too long to verify that it gets it. So that's back on UDP. Just some terms here that are going to come in handy. A server is someone who is the authoritative entity for a lobby. So what does that mean? The server is the one in a client-server model who says, okay, I am going to be sitting here, quote, hosting, so providing availability of some service or game, and then other clients are all the other participants who want to play with that server that aren't authoritative and aren't the server themselves. So the intricacy of the client-server model as it pertains to video games are that clients never directly very, very seldom do clients directly communicate with each other. They relay their information from client A to server, and then server will decide whether clients B, C, D, and E need that information and send it if so. Does that part make sense to everyone? This is like going to be foundational, so I want to be sure this is clear. Are there any questions so far? So this is a brief example. This is taken from the Source engine, so it's made by Valve. They also make Steam. So do you guys remember Tick from Unreal? Yeah. Who's seen Tick in a blueprint? Anyone? Okay, a couple, 1, 2, 3, 4. Okay, a couple of you. So Tick is an event that fires every frame. So a frame is the smallest discrete unit of relevant time in a game, because your game's engine will have to process everything that is relevant per frame by the time the next frame is ready to be shown to the user. So it wouldn't make sense to break up the time any smaller than whatever the maximum time it takes to render a frame is, because then it would the game engine you would be busy waiting on the CPU anyway. So anyway, that's what a tick is. So a good example here is at tick 130, so at frame 130. The server simulates world 33 times per second and sends 20 snapshots per second. So what that means is over UDP, the server will send the client 2 ticks at different varying time intervals. The client will say, okay, I am polling my user's mouse at 33 times a second, puts that into a ring buffer. So a ring buffer is a fixed length array that fills up right to left and then empties left to right on the other end. I think I got that right. Anyway, not really important. But that data is sent back from the client through user ticks to the server, which will then decide what to do with it. Does that make sense? Does everybody see that the server is the one making authoritative decisions here, and the client is essentially just feeding it information? Yeah? Is that a question?
Why are the ticks doing that? No, it's super graphics. It's the snapshot of 120 is getting to the client, which is at 150 right now. And so the next thing that the client is going to receive is 120. The next thing is 135, but the server is kind of at 130 right now.
Yeah, exactly. So there's lag, right? It doesn't. We'll talk about lag in a second, but these things aren't instantaneous. Moving on. So, say client wants to shoot something, right? Say you're on a computer, you're on your games, and you have an arrow, and you want to shoot an arrow. The way that needs to happen, and we'll explain why in a bit, is that the client needs to tell the server that this player in the server's frame of reference wants to shoot an arrow. Then the server will actually do the math and say, like, launch projectile, spawn actor, all of that stuff, and then tell the client back that an arrow started where the client wanted to shoot one. And similarly, the server will also tell every other client how and when that arrow spawned. So the subtle difference here is that if the client just did this locally and said, like, screw you server, I'm telling you I'm shooting an arrow, no other client in the game in that same server's lobby would have that information. And that's why it needs to be relayed back to the server and then to everybody else. Is everyone with me so far? I'm going to keep doing these checks because this is a lot, and I want to be sure that we're all on the same page.
Every time multiplayer you shoot, you're not going to get it until like 20 ticks. You're not going to see it.
Depending on the way it's implemented. So there's, like, AAA games have a lot of hacks around making this stuff super efficient. So they may, like, what they'll probably do is start playing the animation on the client before the packet gets to the server, with the assumption that it'll eventually get there and the difference in time won't be that far, because you don't want to actually you don't want the user to see that there's lag. So you can, like, make some assumptions and, like, hope that it works. But if you hope that it works and it doesn't work, you'll get, like, actual frame lag, which we'll talk about in a second. But that's a very good question, right? So essentially, if you want it to be guaranteed, you would have to wait for the server to acknowledge all of your decisions before doing it. Anybody else? Any questions? If you have anything, like, you don't need to raise your hand. Just, like, interrupt me, and I'm happy to answer. Okay, so hosting and joining. We've talked about what a lobby is. We've talked about what a server is, and we've talked about what a client is. The basic concept of hosting and joining is that game engines, Unreal being one of them, provide an abstraction layer over all of the I want to send 4 bytes in 2 packets to client B. They instead provide an interface that's described solely as I want to host a game, and I will be the server, and I want to allow clients to join the game. So what we're going to be discussing today and what you guys are going to be implementing is a system based on Steamworks Network Subsystem. That's like a mouthful. Basically what that means is your games will utilize the Steam, as you guys have seen, the Steam VR app, the Steam provided multiplayer services, so you don't have to write your own servers, you don't have to send these packets. We're just using the stuff that Valve provides for free. So, like, yay, because that would be really hard if we didn't have it. So yeah, the only trick here is that, and this is mentioned on the slide, is that the difference between a client and server should only be visible to the programmer. Like, a server in the game should never be able to see things faster, do things faster, have any kind of reasonable advantage over the client, because that would ruin your game balance, right? It doesn't matter. It shouldn't matter whether I start the game or whether Emily starts the game. That would just break things, right? So that's something we always have to keep in mind. There's also a concept of a dedicated server. I'm not going to go too much into this, but the basic idea behind a dedicated server is that for each game lobby, the game developer owns some server in some farm and wherever, and every player is a client, and say like 64 connect to each server that they have in a box somewhere. That's the basic idea behind a dedicated server.
I'm really not actually doing that question, but I guess why is there any player on this server? Like, why isn't every player on? Is that the whole point of the dedicated server?
Exactly. So in production games, right, like if you're playing Call of Duty, you don't have to rely on like my internet connection to power a game lobby. So that's why you have a dedicated server and some server rack that has super fast internet that just allows for every player to be a client. Also, if you think about it, if you're deploying a real game, if you let a player be a server, that player could theoretically like turn on and off their internet connection at really, really precise intervals so that they can like hack things and then not tell other people what they're doing and then like turn the internet back on and they'll like teleport across the room. Right, so that's why they don't let you do that generally in games. Any other questions before I move on? Okay. All right, so this should be familiar if anybody has ever touched an Xbox or a PlayStation. This is what a game lobby looks like. I take no responsibility for the names on the screen; they're not mine. But this is from Call of Duty. Like you can imagine, there's some server. They're waiting for 3 players, and there's 15 or however many are in this lobby. But yeah, so Everyone who has played a network game has probably seen lag. What is lag? No one really knows what lag is, other than if you're doing bad, you generally say, I'm lagging, so that people don't think you're actually bad. So lag is the concept of packets. As we said, UDP delivery of packets is not guaranteed, right? So lag is the concept of packets that get, quote, dropped or don't get to their destination between time interval like A to B. And then by the time those packets have been dropped, something is drastically different from when the last time a packet actually got delivered. So some genius on YouTube made this video that explains what lag would look like in real life. No, ruined my video. Okay, we're going to try this again. So that's what it would look like in real life. So you can see, like, ideally the guy who now looks like a total goofball running into the garage door would theoretically be walking in a consistent pace through this, like, right through the middle of that video. But because of some frame lag, the last frame the server got was him running in place, like, over where my mouse is. And then he dropped a bunch of frames. And the next frame the server got was when he was over here. So all of the in-between frames were dropped, and therefore the game state became invalid between the server and the client, right? If the client and the server don't have the same exact information, there could be state validation problems saying, like, you know, what if instead of running into the garage door, he was running off the edge of the level, right? And then somehow, like, frames got dropped and he ended up, like, off the map and, like, dead, right? That's what frame lag is. So the gamer in me also wanted to show some other funny lag montages. Some guy made this. But you can see how this can have a drastic effect, and, like, this is a multi-billion-dollar game. So let's see what these, like, reference lags that they're showing is. Okay, so, like, where'd he go, right? No one, I mean, you have to think about it that the game, okay, so Bungie made Halo. This is Halo for anybody who doesn't recognize it. Like, what just happened, right? he like, should have meleeed someone in the back, which in Halo kills them, and then he died. Or she died, right? Like, you can watch this. Like, I spent, like, way too much time watching this because I thought it was funny. But let's see what happens. Yeah, so people disappearing, right? My point is, if you're doing this in a production game environment, this stuff can become super important, right? Because, like, nowadays with video games and with that kind of whole world, there's not only people, like, competing to see who's better at the game, but there's, like, a lot of money riding on it and a lot of things, right? So lag is important. Number one rule of thumb and, like, the best practice with games is that you don't want to send unnecessary information over the internet if you don't have to, because the more you send, the higher the odds of packets are being dropped. So all the funny lag videos, that's the point I wanted to get across. So we've talked about multiplayer in general. Now it's time to get into exactly how Unreal does things. So Unreal Engine, as I said, provides an interface and abstraction over multiplayer through a thing they call the multiplayer subsystem. So basically the way this works is, you guys are all programmers, you all know what an interface is, I'm assuming, right? That's a familiar term? Yeah. Yes? Yes? Okay. So you imagine that Unreal provides the user, or the programmer, I should say, an interface through blueprints of a bunch of functions that act the same way underneath, regardless of how they're actually written. So this node right here, right, join session. All that means is, regardless of whether I'm using Valve's multiplayer services, or if I wrote my own server, or if I'm just, like, playing over, like, Bluetooth even, it doesn't really matter. That node will always join you into someone else's game. And the great thing about this for us is all of the code that powers the Steam subsystem is written, and we have it, and it's like 80 meg of just, like, code. So that's a lot. That is big. We can just use that for free and take advantage of it. If you wanted to write this from scratch, I would not be qualified to teach you how. Like, you would have to get someone who's, like, a distributed systems expert. There's a lab over there. Go ask them. I don't know. But yeah, so just I want to show a couple more examples of nodes, because this is what you guys are going to be writing in your games. So let's just traverse this blueprint graph. I'm going to walk through it. Someone tell me step by step what's going on. So just shout it out and raise your hand, but this is really stupid. What does this do? Post game event, okay. That hosts the game? Yes? Good. Show a loading screen. Everything is so self-explanatory. I love it. You show a loading screen. All right, so here's where it gets a little bit tricky. Create session. So create session is the blueprint term for saying host game. We talked about what hosting and joining are. This takes in a player controller. We'll talk about that in a minute. Public connections, so the number of people that can join your game as clients. And then use LAN as a boolean that says whether you want to play over the network or whether you want to play on your local router's local area network. So something that we kind of alluded to but not fully described in Unreal is what the player controller is. Basically, the way to think about it is each player in an Unreal game has their player character, right? So you guys have all seen first-person character. You guys swap the gun for the bow. That stuff sounds familiar, right? Yes? Okay, good. First-person characters each correspond with an index-driven player controller. So player 0, for example, will always refer to the local computer. So whenever you say get player controller index 0, you're getting the local player controller. So the player controller corresponds what your local person is doing. And what the player controller does is maps not only input to the character, like the actual first-person character mesh, it also is the way that you refer to different people over a network game. So if I was on the server, and this is where the blueprints will become really tricky, if I ran this on the server, and I said player index 0, I would get back the player controller of the server. Now say there's 2 people in the game. If I ran this and said get player controller index 1, that would get me the other client, the second person that's in the game. But if I ran get player controller on the client, and I put 0, it would give me client, right? It wouldn't give me server. And if I ran it on the client and I put in get index 1, the client would actually return null. And that's because the client doesn't know about anybody else besides itself. That's the client-server distinction, right? So you can only run get player controller index 0 on the client. Any other index will not work. You have to do that stuff on the server. Does everybody understand how that's an interface abstraction over the client-server model of saying, like, servers have full knowledge of everybody in the game, but clients only know about themselves? Was anything about that tricky? I mean, I know it was tricky. Was anything about that confusing, or is there anything I can better explain?
So then when we write the project, then we will have 2 different levels for server and for the client. Where what the server would deal with create a session and rendering, getting the response from the client and then do stuff, versus the client only just every time anything happens to the client will just tell the server that. Exactly.
So towards the end of today's lecture, we'll talk about how to write code that does different things based on whether you're on the client or the server. I have a couple allegories to pen computer science classes that I'll make at that point, but just for now, assume that we'll talk about that at the end. Any other questions on this so far? Okay. If you guys are silent, I'm assuming this makes total sense.
So this is in its own blueprint, or server blueprint.
So you can call create session on any character blueprint, I believe.
So this goes in a character.
Yes. I have to check on that, and when we do a demo after this, I'll actually test and we'll see it. You either have to call create session from the game state object, which I'll show. I haven't shown you guys game state yet, but there's a couple generic objects that are in every sorry, I'm getting ahead of myself. There are a couple global objects in Unreal that you can access from any blueprint, and some of those are game state, game mode, and then get player controller is another good example. So I'll show those in the demo, but the idea is you need to call create or join session from some global object. That's why I didn't think it was the character. And then at that point, your game will transition from being in the single player mode where none of this network stuff is relevant and actually connect via XML-RPC to the other thing, and then you'll be in the same game together. That was a long, belabored answer, but I'll show you at the end where you can call create session. How about that?
I guess I'm confused with why they would create it in character as opposed to. I guess it's is the character
Yeah, so that's why I'm like now 90% sure that it's called from game state or game instance, one of those two. So game state describes like state variables of your game, and game instance is like the running. You can picture that as like an allegory to the process. Does that make sense? And you probably call it from game state or game instance, I have to imagine. I don't know for myself, but if whenever I forget, I just right click, type create session, and if it doesn't come up, I know it's in whatever the other one of those is. You know. So for your projects, you're going to be using Unreal's Steam subsystem, and I'm going to show you how to do that. But so you essentially will always put false into where that enable land boolean is. Anybody else? All right, so this is going to create a little bit of a complication for you guys in your games, right? From what I saw in the demos, not that you should have done this, and it's better that you didn't. Nobody has like a menu or a lobby or a way to actually say, okay, once I start the game, I'm not immediately like shooting arrows at people. There's some setup that you need to do. So essentially you're going to have to build methods and build ways for your players to actually say, I'm hosting a game, and then teleport me into the level where I'm playing. Or I'm joining a game, so show me all the available games I can join, and then when I do some action, join one of them. So the idea there is that all of these blueprint nodes, so host game event, show loading screen, create session, all of this stuff will have to be tied into some visual representation of how your user will be interacting with them. Because your user can't like just type create session in their end, right? They need to do something. So some creative ways of doing that are like super easy because you guys are, well, easier than doing them from scratch since you guys already have this stuff, is if you made another level, like another scene in Unreal, and then like put your character in there with the bow and arrow, and then say there's like a button to say like show me all available games. And then you get back the array via a blueprint node of all of the available games. And then say for each game you make a sphere somewhere in your scene and you put a little text that says what the name of the person is who's hosting it. And then maybe you shoot the sphere with the arrow and it joins the game for you. Right, there's no need to reinvent the wheel here. Like my point is that you want to reuse whatever you've made so far so that there's not more than one input mechanism that'll just confuse your user. So shooting arrows is a great thing, right? You just shoot the one you want to do. And maybe there's another sphere at the top that says like host, and you shoot that and then you host again. So yeah, any questions on that stuff? The host and join logic and what changes that will mean. Okay. All right, so here's where it gets complicated. The way Unreal determines what you actually send across the network, remember we talked about sending only relevant stuff, is via a system called replication. So variables are the first thing we're going to talk about. You guys have all seen variables. They're on the left side of the blueprint editor. Basically what you can say for a variable is that it takes either one of three replication states. Right down here. If you click a variable on the right side of the blueprint window, those properties will come up. So first one, probably the easiest one, replicated. Anytime this variable changes, it will change on both client and all servers who have a reference to this in their scene. Very easy, right? If you have like, what's a good example of this? Say you have a bunch of characters who are like walking around the scene, and you have an arrow that stuns someone. Maybe like you have a variable that's replicated that says, okay, that person is stunned, so change the material. That's relevant to everyone, right? So you probably want to replicate it. Now that might also be a good case for something called rep notify. So rep notify is an abbreviation for saying replicate this event, but also or replicate this variable, but also fire an event on both the client and the server when it changes. So you'll see that if you make a node that says set, normal setter node, and you have rep notify turned on, it'll say set with notify. And then if you have replication or rep notify turned on, you'll see this little thing in the upper right corner, the two dots. That means it's replicated. So this may seem like a lot. So I wanted to take some time to kind of talk about what examples of each one could be. So as I said, player attributes are often very well done as replicated stuff. So how much health each person has, or like where a person is in the level, great examples. Rep notify is the number of players, like maybe the number of players in the game. And who can think of, this may be a stretch, but who can think of why you would want the number of players in a game to be rep notify and not just replicated? Exactly, right? So if you didn't have rep notify turned on for number of players, every time a player joined the game, nobody else would know about it unless you put some extra logic in. So if you didn't have rep notify, you'd probably have to check like every tick, did the number of players change? And if it did, trigger some stuff. That's really, really inefficient. That's like a polling model versus a polling model, right? You don't want to actually spend CPU cycles checking if something changed if you have a way of being told when it changes without checking yourself.
So if you don't replicate something, won't the new thing that happens like appear in your life? So if like something happens to my house, I'm like often replicate, like will it just show up in my world? So like it'll not be there.
Exactly.
Notified every single time.
Well, so there's a little bit of a nuance there. So consider that you're replicating an integer that corresponds to the number of players in the game. Like a player can't see an integer, right? There would have to be some visual effect. So in that case, that's where chaining it to an event becomes useful. Does that make sense? Because you could trigger some visual effect on the event without having to watch the integer to see if it changed. Is that?
Yeah.
Okay.
What's an example of something you learned that
But not rep notify? Good example of replicated but not rep notified. So I think a great example of that would be systems that are already driven off of the variable that is being replicated. So for example, a player's like animation state. So say you had a variable on a player that's like whether the player is running, walking, standing still, like squatting, whatever. That's like some enum. The animation engine in Unreal will automatically make the visual change necessary for that player to go from running or walking or standing or sitting still, and you wouldn't have to fire an event to change that yourself. But maybe you need that variable so that both the client and the server can change it. Does that make sense? So it's like, it's an abstraction over saying instead of me like going to the server and saying go change this variable and then send me the new value, if it's replicated and you change it locally, it'll change on the server as well. And that it'll do all of that stuff under the hood for you. Was that?
Yeah.
Okay. Any other questions on variable replication? Okay. Trusting you guys here. Next concept. Not only can you replicate individual variables, it would be great to be able to replicate events. So we talked about how rep notify generates events, right? What if you already have an event in your scene and you need that event to be run on either the server or the client or on both? You'll notice that if you change an event signature to be replicated, it'll change what it says here. It'll say, target is third person character, whatever, replicated to all if server. So we'll talk about what those three different types of replication are. Real quick, I should have mentioned this earlier. Who has not seen an event in Unreal yet? You guys have all seen events? The little red things? Like that one? Okay, great. So we all know what an event is. There's three types of replication for events. The first of which is multicast. So what multicast does is say, that's what corresponds to this little blurb right here, replicated to all if servers. So multicast will say, if I'm the server, and only if I'm the server, perform this action locally and go tell every client to perform it as well. So that's like make happen everywhere. Run on owning client means that whenever that event is triggered, it only runs on the client that said like go do something. So if I had a client and the client was saying like, what's a good example here? So sorry. Say there was an example of if you're on your client, right, and there's something that happens ambient in the landscape, right, maybe every like 15 seconds, like the clouds move or something, right? Those clouds moving on your client are not relevant to anybody else. Like nobody cares where your clouds are. That only matters to you because you're the only one seeing them. So run on your client could be an event that's triggered off of a timer that goes like every 15 seconds, move the clouds. But you wouldn't want to replicate that because it's not significant to anybody else. That's a great example of what run on a client would be. The last one is run on server. So when we talked about the initial example of shooting a bullet, you would basically want to say, if you had an event that says like on pressing left mouse button, shoot bullet, you would make that event run on server so that you tell the server, go make this bullet and go shoot it. And then you'd make that bullet variable replicated so that it goes everywhere else after the server has done it. Now there's a subtlety because you wouldn't want shooting a bullet to be run on all, which would be multicast. Can anybody think of why you wouldn't want to multicast shooting a bullet? This is a really in-depth question. Jason?
So we don't want other clients who can't see the bullet to know that that bullet is spawned.
Sure, but say you're shooting Henry, and I'm here and I can see that, right? I would probably want to know, right? So, close. Krishna, is that a hand?
Just because, it's like the more interactions and stuff that cost they'll do the same exact thing, it's just the bullet being replicated.
Exactly what you said, but not the network part. So if it runs on every client and the server, what could be different about the state of each client? Like, remember the diagram that said the ticks were in different positions? So what happens if it goes to the server and then it goes to a bunch of clients and the clients are a frame behind? There can be drastic changes in the way that shooting happens or the results of it based on what the difference in tiny fractions of time is. So instead of, if you did it as multicast, right? So say on the server, I'm here and I shoot a bullet. Now say on Ed's client, I'm all the way over here because I moved, but the server hasn't gotten that yet and I shoot the bullet. It'll go somewhere else. That's bad, right? That's why you do it as run on server. Does that make sense?
So when we just track the position of the bullet goes.
Exactly. So you would do run on server and then the bullet itself would be replicated so that whenever the bullet moves, it triggers a movement event. Right.
No, I mean more on this multicast. What is multicast?
Sorry, say that again. What is?
What's the difference? Why do you use multicast?
So, I'm trying to think of a good example of why multicast would be useful. So, say multicast is useful for when you need something to happen for everyone to see, but that action isn't gameplay mechanic significant. So say there's an ambient event in the game where maybe it was sunny outside, but all of a sudden you want it to become rainy for everyone. Now notice there's a subtlety there, right? It's not when I made the statement earlier that it doesn't matter what one player's clouds are for every other player. It would matter for every player if it was raining or not, because maybe that affects. You wouldn't want one person to be in the same level and it to be sunny, and one person to be in the same level for it to be rainy, right? That wouldn't be good. So what you would do is you would multicast that event, because it doesn't matter if it fires 2 milliseconds late on your client, it just will happen. And the significance of the timing delay is not relevant.
Right, so that means that, so run on server means there are not much delay over all other times, but multicast potentially good.
Well, also consider that run on server will only, if you do something as run on server, it will only show up on the other clients if whatever you're doing as a variable is replicated. So if I said run on server and I said do something to a variable that isn't replicated, it would only show on the server. But if you say run on server for a variable, not an event, that is replicated, it would show everywhere. That's the difference. It's basically multicast is similar to saying run on server with variable replicated. So do something to a replicated variable, because they both achieve the same effect of it happening everywhere. It's just that if the variable is replicated, the behavior is deterministic for how it happens. But if it's multicasted, there's going to be frame delay and it will not be deterministic. Does that better clarify? Yep. Does anybody have any questions on those three before I get to reliability?
So how authoritative is this server? I guess if the client, so the client's calling run on server, and that triggers some event that the server that handles.
Mm-hmm.
Now, if we're writing anti-cheat logic or anything, would we have to add extra logic to the server? Or?
Yes.
All right. So Unreal doesn't have all right. So that doesn't take care of because obviously the client could just hack in their own run server.
Exactly. So you'll find you make a great point. And I should mention that there are hundreds of these tutorials on YouTube that will explain and talk you through making a multiplayer game in Unreal. But those were a little hard to follow for me because they were 3 hours long, and it wasn't a class, so it was a little different. But Tim makes a great point that if you have say you can have a method that's tagged as run on server that's win game. If some client is smart enough to hack their local copy of the game so that they can trigger that event signature from anywhere without actually having won the game, that would be really bad news, right? Because then any client could arbitrarily win. And that's how game cheats and if you've ever played games where you can have something like the concept of a modded lobby or like a hacked version of the game does something different if you host from there, that's what that is. So unless you purposefully defend your code against people's like indiscretions with what they call on their clients, you can have like cheating issues. Luckily for you guys, like, okay, if you really want to cheat in your own game, let's go for it. I mean, you know, that's up to you. But in the real world, that is a significant consideration.
So when we're talking about the bullet example, you mentioned that when you're running on the client that you get some that bullet motion directly client. So like if the server child and then definitely running on the server, but if the client child, does it also be on the server or do you run it on the other client?
No, so that run on server will, if it's the server itself, it'll just run. And if it's client, it'll send the message to tell the server to run. So for the bullet example, the reason you would want it to be run on server regardless is because exactly what you just said. If it was run on any client, the trajectory of the bullet would have different effects based on the time at which it was fired. But if it's run on server, the math, like, if it's run on server, then clients themselves don't calculate the trajectory of the bullet. They just get information as to where it is positionally, and that is deterministic. Does that clarify? No, so that event itself would be run on server, and then the bullet itself, like the bullet blueprint, would be replicated. So that the bullet's position will inherently replicate regardless of what else is happening in the game. And so when you call like destroy, it'll destroy everywhere, right? Great questions, like keep asking them.
So I guess if you're like replicating a bullet, does Unreal have like interpolation below it? Or
Exactly. So great question. If we have, okay, we're not going to have time today, but on Tuesday I'll show you the replication settings for an actor. So we talked about variable replication. Actors and components also have their own replication settings, but that stuff is more advanced than what I'm showing here, so I wanted to do this first. Actors have not only replicate this, but they have replicate at this frequency, reliable replicate at this frequency, like control how many times it's pulled per interval of time. And then there's also a thing that says replicate this if the other player is within X units of it happening, so that you don't replicate stuff that's outside the field of view of one person if you don't need to. So it's like super intelligent, right? It saves a lot of packets that way. But yeah, more on that Tuesday.
I feel like it's always just like all of this stuff because you have to like manage every single kind of event as where you want to run. It like totally changes how you develop. Like it's not as simple as like if you're developing like single player game and you just like add some project to it multiplayer.
Well, so I think this may seem daunting right now, but the only changes you'll actually have to make in your blueprint will be clicking an event and changing it to run on server, run on multicast, or run on client. Like there will not be significant logic changes. It'll literally just be tag a variable is replicated, tag an event is replicated, or tag an actor is replicated. And for example, the first person character is already configured for replication by default. I didn't tell you guys that because like I wanted you to go find it yourself, but everything you've done so far is already set up for this. So thumbs up there. But yeah, so don't worry, it's not going to be a significant like add 1,000 nodes, you know. Any other questions? I really appreciate this and like keep asking them. Is that a hand or is that a head scratch? Okay. All right. So last thing here, we talked about how these events, well basically how packet sends are unreliable because you're spamming the network so often, right? So events, unlike variables have it, I think variables don't have this. Events have a toggle for reliable or non-reliable. So if you have an event that's like end game, you probably want it to be reliable. So if it's reliable, it'll send over TCP instead of UDP. This is all like internet protocol base layer stuff. But just know that the reliable versus non-reliable target either guarantees or does not guarantee delivery of that event. If you don't need it to be reliable, do not make it reliable because it's way slower. Just general concept. Exactly. Yes. Yeah, so if you make more things reliable, you'll have more TCP calls that are blocking. So instead of spamming the network, you're going to like busy wait machines. Does that make sense? It's a different choke point on the, yeah. All right, so we talked about this. Just to go over it again, multicast is things that are environmental effects, not gameplay significant. Run on an owner client is stuff that's only relevant to the owner, and server is stuff that's gameplay mechanic relevant to everyone. Reliability we also just talked about. So the last thing, and this was alluded to by Jason in the beginning, there's the concept of knowing whether you're the server or the client, and that's done via a blueprint node. There's switch has authority, so it takes in execution, and then you connect nodes to either server or not server, and then you drive logic off of that. So there's also, this is an execution switch. There's also a thing that gives you a Boolean that you can decide your own logic, like if you want to AND it with something, you don't have to use this one. But yeah, if you've taken 380, or if you know anything about operating systems, calling switch has authority is the same thing as calling get PID inside of a forked process, right? So if you have, the idea is that your blueprint, in multiplayer games, your blueprint will be executing simultaneously on both server and client. So if you need to drive logic that only happens on one of them, you need to surround it by a has authority statement. Is that clear? Okay. All right. I think that is everything. Yeah, last thing. So we have like a minute left, but I wanted to show you. So I wanted to first acknowledge that I got a lot of good feedback from you guys on the 3JS project, and thank you for being honest and like what you thought we could have done differently. Because like you're not going to offend us by saying any of this, and the more we get, the more we can make the assignments better in the future. So one of the things that we got feedback from was that we kind of just said like go make it VR. We didn't tell you like go use VREffect.js, VRControls.js, Orbit.js, whatever. So something that I want to just hint at today, and something that we're going to discuss in detail on Thursday, is exactly how to get your Unreal game from the state it is now to a fully multiplayer supported by Steam game. So there's this article, I will link it in Slack, and it's pretty, well, I won't say it's simple. It's actually quite a lot to do, but this thing explains exactly what you have to do at every step. So the idea is you have to go download the Steamworks SDK, copy a couple of DLLs, which are compiled code essentially, and then put these lines of configuration in your game's config file. So I have office hours from 4 to 6 today. I will be here to help you guys do this, and I can even like run it like a tutorial where I just do it in front of you and you can follow along. But yeah, so there's just like, this is exactly how you get it set up. There's no ambiguity as to do I need to include this JavaScript, like just follow this. So that's it for today. Thank you guys, and thank you again for doing your demos. Much appreciated. I was happy Norm got to see this. So yeah, great job.